Okay, for results and discussions. Uh, First, let's talk about synthetics of highly allied CNT sheets. Floating catalyst chemicals vapor depositions FCCVD used in this work has a great potential for productions of large area CNT sheets with excellent electrical and mechanical property. In Figure 1A, show their uh, schematic illustrations of the synthesis process for the highly allied CNT sheets. CNT consists of multi-wall CNT having 5 to 7 walls with outer diameters of about 50 nanometers, as shown in Figure 1b. The synthesized CNT contains small amounts of ions characterized of 7.6% weight, as can be seen by the change in mass from thermogravimetrics analysis (TGA). There is a high degree of alignment in the widening directions of the CNT web, which is described in Figure 1C and 1D, corresponding to heightened electrical property. Moving up to thermoelectric properties of highly aligned CNT sheets, the performance of TE materials is evaluated by a dimensionless figure of merit CT, which is defined as CT equal h squared sigma T over K, which S is Seebeck's coefficient, sigma is the electrical conductivity, and K is thermal conductivity. It is seen that the disorder of bulk computers MWCNT sheets has a relatively low uh, electrical conductivity, 1.3 times 10 to the 3 compared to the SWCNT due to its low M, and carrier mobility 0.08. TEG usually consists of P and N type electronic excuse me, electronically connect in series and thermally connect in parallel to achieve maximum device efficiency. Moving up to continuous modules designed for minimizing circuit resistance. Traditional TE modules are generally arranged in a way that the temperature gradient is formed along the in-plane directions of each leg. The flexibility of and mechanical stability of the CNT sheets of system allow for a great degrees of freedom when designing module type of structure. Model B in Figure 2b has exact same design as fabrications method as Model A, but was prepared by using the highly aligned CNT sheets. Model C is in Figure 2c show the continuous design based on the highly aligned CNT sheets without metals electrode as we propose. Okay, for fabrications of prototype FTEX TEGs, to utilize a freestanding FTEX, we fabricate a flexible support with PDMS by using a homemade stainless steel. By adopting the continuous modules design, the DOP CNT sheet was opened into PDMS support unit to create FTEX device that is electrically in series and thermally in parallel. Eventually, the DOP CNT sheets phase inside and covered by PDM support unit. The as fabricates prototype FTEX show excellent flexibles and durability due to the continuous design flexible fabricate. With a single CNT sheet, this architecture is ideal for real-world implementations because when the FTEX is explored in strains by being bent or patched, there are no physical interconnects to reach of the failing. Okay, for the last part, demonstrate demonstrations of variable TEGs. Finally, to demonstrate the biothermal harvest of electrics by body heat, we were the prototype F takes as a rich band as shown in figure 4a. We achieved 3.4 millivolts of electrical potential directly convert from body heat without mechanicals moving part. When the delta T was 7 Kelvin, this is noteworthy that generally the voltage per unit weight of the prototype FTEC it's around 170 millivolts per grams. Due to the lightweight nature of CNT sheets, nearby only 9 grams of CNT sheets is needed for generating the same potentials of 1.5 volt that standard AA batteries produce. These results show the great potentials for powering personal wearables electronics devices. Moreover, to investigate the device reliabilities under mechanical stress, we measure the change of circuit resistance of the modules under the bending status. As can be seen in figure 4b, there is no significant increase less than 0.6% of the circuit resistance, which imply high flexibilities and electromechanical stability. Furthermore, for FTEC was repeatedly bent up 100 circles with bending regions of 20 millimeters, which also exhibit stable circuit resistance less than 2.3%. Therefore, the present FTEC is mechanically robust, providing opportunity to reconfigure into various conformal structure, which would be a strong benefit for harvest biothermal energy.